Yes, sir, last part.
Walang audio? My gosh.
First part, sir,
Oh, all
meron.
right. So anyway, what have you tried to hear or her? Have you heard anything that attached? Uh, what I mean is that heard some kind of like a term. Meron ba kayong term na parang tumatak sa inyo dun sa Kmeans? Okay. May tumatak ba dun sa video? Wala. Wala. Okay, so
Meron naman, sir.
we will be learning K-means clustering on this session today. So K-means clustering is a kind of learning algorithm or learning methodology, which is unsupervised. So let me just provide you with some differences between supervised and unsupervised learning. Okay, so let me try to use this Jamboard. Okay, let's write supervised versus unsupervised. Yeah. All right. So let's me have a ball pen here. Okay, so this is my drawing pad. Okay, so let's talk about unsupervised learning. But before that, let's review ourselves with supervised learning. Okay. So when we do supervised learning, we provide a target. Okay, we gave targets to our data set. So what are examples of data sets that are for supervised learning? We can use the iris, iris, iris data set. We can use the Boston, Boston house pricing data set. What else? The weather data set, weather. So those are the data sets that has a prerequisite that we provide a target. That's why it's called supervised learning. And so for supervised learning, we have machine learning algorithms to use. So these machine learning algorithms are regression style algorithm, and we also have logistic regression style, so logreg, type it there, and others. But most of the time, it implements the usage of targets. So targets can be, can I have a new page here? Targets can be like, for instance, our data set has attributes. Let's say your data set is a matrix. Okay. Let me just align it properly. And you provide a target in the end. So this is your target in the end. So usually your target value is a continuous value. Let's say 27, 30. It's a total random number. So I call this one a regression problem. So what are those regression data sets? Like the Boston data set, where we want to know the estimated price of a house. And what else? Anything or any data that the final output is a prediction with regards to price. We can also use estimated sales. So that is also considered continuous values. But whenever we have a data set which also has a target, and the data set is having a target of nominal values, such as, let's say, uh, class 1, class 2, class 3, or sometimes it's yes or no. So it's a classification type of uh, supervised learning. But the bottom line there is it has a target. Okay. So let's go back to the concept of unsupervised learning. Unsupervised. So this one, if we're talking about targets in our supervised learning, in the unsupervised learning, we do not use target. So the data set of the unsupervised learning is usually just attributes without a target. So the target is missing, or the target probably was removed because we are going to do a unsupervised wise because we were going to use unsupervised learning. So the target should not be considered part of the data set. So let me show you an example of a data set that doesn't have a target. So we have here the data set, zoo data set. Okay, so this data set actually has a target, but what we can do about the target is we can remove the target. So how many are the targets? There are different kinds of or classes of animals. You have mammal, bird, reptile, fish, amphibian, bug, invertebrate. So the data set is actually, I think it's just 7. How many rows do we have here? Can I download this one? So I need to register first. Okay, let me just. Download ko lang siya saglit. You can also download the data set too if you want. But this is an interesting data set because I can implement some pre-processing here. As I see that the data set only has seven rows. Is that correct? Let me confirm. The zoo data set. Okay, so this is the zoo data set that I have. Let's try to analyze the data set. So we have here the name, the animal name, the hair, feathers, eggs. So these are the features of those animals. So we have here an aardvark. It has hair. It is a predator. It has tooth, backbone. It breeds. It does not swim. Venomous, no. Fins, legs. It has 4 legs. And it has a target. As you can see, the target is present on our data set. In, uh, in unsupervised learning, what we want to do here is we let our machine try to determine the organization of the feature by means of clustering them or putting them into a cluster or nearest neighbor, something like that, but without the target. So we will not provide any facts or any information regarding to what is the class of that, let's say in this data set, the animal. So we will try to remove later the class type. So this is why I'm saying when we do our clustering, we remove the target. So obviously the target here is this one, it's the class type. Later in our Python code, we will try to remove this target. All right, so let me just close this for the meantime because we will explain more about clustering. Okay, so the Kmeans clustering is, it has pseudocode or it has steps. It has steps to follow. So number one, it chooses we can provide a random number of clusters. Okay. Then next step is it will place, or the program will try to place the centroids randomly. Number three, repeat steps 4 and 5 until convergence, or there is no more variation on the what we call centroids in our cluster. So for each data point, find the nearest centroid and assign that point to that cluster. So for each cluster, there will be new centroids if there is the very near cluster. So this is also the diagram for K-means clustering. So basically, looking at this GIF or this animation, it summarizes the explanation that I just told you, that first, the machine tries to know where is that point located randomly and tries to estimate and converge into the middle based on recalculating the centroids as it finds its nearest its nearest data point. Okay? So meaning, una, nagkakaroon siya ng random na selection. Kung mapapansin ninyo, the triangles are positioned not optimal. It's away from the circumference of the cluster. And in time, it tries to move its way up to the center of the data. And what are those data that are scattered? That is what we want to optimize. We want to know the area of the cluster, and afterwards we can label those cluster. So what is important? What is the importance of clustering in our data set? The importance of clustering in our data set is that if you have a data which, let's say, a sales data, you might want to cluster them to provide some kind of uh, familiarity with, or a pattern that there is a certain kind of cluster on your data set. So this is a part of exploratory data analysis where we use machine learning to know if there are patterns or clusters on our data set. Okay, so going back to the zoo data set that we have earlier, there are some instances that an animal can be a mammal, but it lives under the water. Is there any animal that you know that is a mammal, but at the same time living underwater? Could you guess what kind of animal is that? What are mammals that are living also underwater? So the usual characteristic of a mammal is it has hair, it breathes air rather than using its gills to convert oxygen from the water. And it has mammary glands, or other words, breast. Usually a mammal has breasts. Okay, that's what I mean when I say mammary glands. I believe that's uh, coming from your biology class. I don't know. A seal. Yeah, probably. A seal is a mammal, but also swims in the ocean, right? So these nuances can be detected by using sea lions then. Oh yeah, yeah, yeah. How about dolphins? Are dolphins mammals too? Okay. How about whales? Are whales mammals? Dugong. Yeah, got it. So so these are like the nuances which a normal person could possibly have an error. Okay, because these are nuances that only the machine could provide us by means of the mathematical computation. So the mathematical computation that is used in the K-means clustering is the Euclidean distance. So what you are going to do there, what you're going to do there is to compute for the Euclidean distance of all the data that you have. Let's say if we're going to return on the zoo data set, we need to normalize it. Yeah, later we will try to explore that. So that's what I mean when I say it's important to use uh, clustering algorithms, because in our data there are some kinds of like nuances that it's hard to predict or determine easily with our senses, obviously with our five senses, seeing, looking, and just observing. It's really hard to know that kind of nuances. But by means of K-means clustering, a machine learning algorithm for clustering, we can detect those nuances. So where can you also implement clustering? You can implement clustering also in anomaly detection. Let's say you have a spaceship. So it will provide a status of different parts of your ship. So by implementing K-means clustering, if the provided status is outside the usual clusters, it means there is something wrong. Okay, something wrong on the data. I mean, something wrong on the spaceship. Okay, so there is actually an Excel file here. So this Excel file, let me just load it. Open it with Google Sheets. This is the computation of K-means clustering, the manual way. Yeah. So what we have here is we have a data set. So this is our data set, X and Y axis. And then we plot the data set, which is K1. K1 is the distance between some points. So if I'm going to plot this in a scatter plot, let's wait for it to load. Okay, can you hear me now? I think my internet connection is fluctuating. So let me just use a visualization tool to draw or to create a chart. So the chart should not be line, should be a point, something like this. Okay. So this is the visualization of our data set. So our sample data set is 185 and 72. So this is an example. Okay, by observing at it, there is some kind of like a cluster. If you will see, if you will see, right, there is already some kind of like a cluster here. Or can I? Okay. transparent. Okay. As you can see here, there is already some kind of like clustering on our data set, right? Copy. Ayaw niya mag-copy. Oh, ayaw niya mag-copy. So, ito yung dalawa nating data set, no? Sorry, dalawang cluster natin. Ito yung apat, ito yung dalawa. So, napapansin kagad natin that there are four nearest points to each other and those two farther away. So once we plot them, usually that happens, and what is happening is we need to know the center. We need to know the center of the centroid of our K-means cluster. So this is the manual computation of how to find the center of our cluster. So what will happen here is if we're looking at what is the distance of 185 to 185? Nothing. So therefore, it's 0. Right? So what is the 185.72? And then for K2, so we check that there is 185 to 72. So it has 21. So therefore, we don't update the centroid of K1. Yeah, so basically it's just computing for the centers and finding the optimal path on our center. I believe there is a video of me explaining this one somewhere on my YouTube channel, so you can just view it there. How did I explain this one? I think there is the title is cluster algorithms, something like that. So to be honest, I forgot the computation with what I did here. Center part of the center part of our our this one scatter plot. So parang ganito yung mangyayari sa kanya. So sa umpisa, malayo yung centroids. Then makikita niyo yung pinaka-center based on the computation of finding the least distance. Okay, finding the least distance. I think what we can do there is just find the distances like so. Now let's proceed with our sample here in our Google Colab. So we will be using Pandas, Matplotlib, and sklearn using the Kmeans cluster. So our sample data set is the same with our Excel file there. So the value is 85, 72, 170, 56, 168, 60. it's the same data. So we will going to convert that data into a data frame. Therefore, it's now DF as our data frame. And to run the cluster, we will just write there Kmeans n underscore cluster, and our cluster is 2. So we decided that our cluster starts with 2. Okay, so we will determine the 2 columns, the column X and the column Y. Then we will say K-means dot fit, and then we will have the new labels, DF cluster. So in the K-means cluster, we usually get the labels of our data set. So what do I mean when I say labels? It also means when we do our K-means clustering, we get the target. But the target is based on the algorithm and not anything else. So it estimates from the given features the target it will place to the data point. So usually in this one, it will just give us cluster 1 and cluster 2 because we denoted that what we are looking for are only 2 clusters in this data set. As you can see in the graph, there might be only 2 clusters in our data set because as you can see, there are 4 points that are near to each other and there are 2 points that are near to each other. And those 2 points are farther from these 4 points. Therefore, we can say it might be only 2 clusters. That's why we denoted the argument as 2 for our cluster. Then what we will do there is to plot. So what does it mean when we say fig and AX? And then we say PLT that subplots. It means we will have 2 plots, figure and AX. So what is the value of AX? So the value of AX is this one. And we will have a declaration of colors. If the label of the color is 0, it will be red. And if the label of the color is 1, it would be blue. So we will create a scatter plot of the X values and the Y values. And C will be the application of the color. Because DF came from this one, the labeling of K-means clustering, if it is 0 or 1, or if it is cluster 0 or cluster 1. Then it will apply the color that we stated here on our dictionary. So it means that whichever the value of cluster, it will try to apply the color based if it is 0 or 1. Then it will produce the graph. Next is what happened. Color pa rin ba yan? It will provide the distances. Okay, so it will provide the distances. So basically, this is just how the program will run. So this code is for visualizing our our cluster. And this one is providing us the distances. So there are two distances that are farther from the 4. Okay. So what if we wanted to put some circles? So this is the code that will put circle on our cluster. So as you can see, it provides area to our cluster. So let's play with our iris dataset. So iris datasets are local in the SK database. So let's play with it. So we will be loading our iris coming from the local dataset, which is iris. So what is the iris dataset? The iris dataset has 3 kinds of flowers: iris virginica, iris setosa, and iris versicolor. So let's try to load our data. So let me have a new line of code, df. Okay. df.columns, let me just look at it. What are the columns? So the columns are sepal length, sepal width, petal length, and petal width. Okay, so by using iris.feature names, it removed the target. Diba? That's what I'm saying earlier. How did I know that the target was removed? If I'm going to look at the iris here, coming from this code, iris is equal to load iris. It seems that our data is load iris. Saan ba siya? Ayan. Frame target names. Ito, so meron siyang target names. Ayan siya. No. Yan yung target names niya. Setosa versicolor virginica. Okay. So pag kinuha lang natin yung iris feature name, ano lang yung papakita niya sa atin? Ayan lang, yan yung feature names. Pero pag iris columns feature. So ito yung target niya, no? So 0 means setosa, vesicolor, and number 2 is virginica. Then, ang gusto lang natin kunin sa kanya, because this is a clustering or unsupervised learning, we just want to look for the different features. So iris, data, it will provide us with the data itself. So target names. So these are the target names: Setosa, versicolor, virginica. So i-print natin. Target names and iris. Ayan. So this is the target names and the iris target. So these are the feature names, and the feature data. Okay. Sobrang haba. Gawin na natin ito. Ay, wala pala siyang head. Di pala siya data frame. Ayan. So this is the data. This is the feature name. Okay, so ang kailangan lang natin dito, all we need to do is to get only the feature data or feature names and the data. So we will not, or we will exclude the target. Okay? Don't worry about that error. It's just that if I run this again, it will not have any error. Okay? So we need to create a data frame from that data set, iris from sklearn. So for the columns, we will get iris.feature names. And for the data, we will get iris.data. So we run that and we create now our features. So again, by doing this, we exclude the target because we did not include the target. We only include feature names and iris data for our data set. That's why there are no more iris information, or there's no more target in our data set. Okay, take note also that our values should be continuous values or numerical. We will not accept any nominal values, categorical values in our K-means clustering data set. So if that's the case, if your data set has strings or non-numerical values, you need to transform that in a way it will be all numerical values. Remember that in the K-means clustering algorithm, it uses Euclidean distance formula or the distance formula of a certain point. So in order to do that, we need to remove all the conditional or all the nominal and categorical values and transform them into all numerical values. Once we are done with that, so this data set already is a good data set for, or a fit data set for clustering, because everything is numerical and there is no more target. We can now fit that on our K-means cluster. But before that, we need to call our Kmeans cluster because we need to set it up. So we set our cluster as number of three clusters. The reason why we use three clusters is that in our data set, this iris data set, we all already know that there are three types of flowers in the data set. So we just wanted to confirm if there are really three flowers only on our data set. So usually the random state is 0 or 42, depending if the number of your data set is larger than 150, it is best to use a random state that is higher than 0. Now, this is our training, Kmeans.fit. And then after the training, we will get the labels or the targets from this data set. So let's run and let's look at our data set. By using this code, df cluster equals Kmeans labels, we will now have the new target in our data set. So this new target is based on the clustering method and not relying from human intervention. So this is mainly computational, or it is coming from the computer, not from a human standpoint. So how do we analyze this in the real world? We analyze this by means of observation. So what is our observation parameter? Our observation parameter is actually the Euclidean distance formula, where you get all of the values of this one computed as square root of 5.1 squared plus 3.5 squared plus 4 plus 1.4 squared plus 0.2 squared. So it will result you the distance of all this points that were given. Okay. So after we get the cluster such as this one, we can now start plotting it and providing the colors of each data point. So where did we get the data points here? It's coming from okay, so it's coming from clustered the underscore df dot iloc1, iloc0 and 1. So let's look at the values of those. So this is the x-axis. Okay, let me just run the program. Run, 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 run. Cluster DF, where? Cluster DF. I need to run this, sorry. Then these are the values. 6.9. And the next one is so we just get one of our rows. Like ito yun, ano? Kumuha lang tayo dito and dito, I guess. Kasi yun yung values niya eh. 6.9 and 3.1. Ayan yung row niya, oh, yung row item niya. So kumuha lang tayo doon ng example and then plinat natin siya based dun sa cluster. So we found out that ganito ang itsura niya. Parang kumuha tayo ng isang column. Pero yung isang column na yon I think is sepal length siguro tsaka sepal width or petal width. Circle, yung circle, nag-create tayo ng circle actually na circle na ano yan, ano ba to? Circle na drawing. Yung circle na drawing, nanggaling siya sa cluster center ng Kmeans cluster centers. And yung radius, galing naman siya sa isang column -1. Then minus siya sa cluster center, x-axis, maximum value of radius. So yung radius na yan, yan yung bilog, yung ano, yung laki ng bilog ng circle. So pag pinag-uusapan natin ng cluster 0, medyo ano siya, medyo malabo yung cluster niya kasi, or hindi naman ganoon kalabo, pero overlapping siya sa tatlo ng mas malaki. Mas malaki yung overlapping niya sa tatlo. Ang ibig sabihin lang nun is meron isang flower na nasa middle ground. Pagka hindi siya masyadong maliit and hindi siya masyadong malaki, nasa middle lang siya. Yun yung cluster 0. Nasa middle lang siya. Hindi siya ganon ka-extreme na malapad. Okay? Kung babasahin natin to, sepal width is kalaparan, di ba? Malapad siya. Then, so, ibig sabihin, may mga flowers na malapad, pero hindi siya mahahaba. Pero malalapad siya. No? Hindi siya kalaparan sa sepal, pero malalapad ang kanyang sepal width. Hindi siya mahaba, makakapal siya, pero bansot, parang ganon. So that is cluster 1. So ganon natin siya interpret. Kasi sa flower, let's say, ayan, ayan siya, no? So, pag mas mahaba siya, teka lang. Pag mas mahaba daw yung kanyang sepal, it's either versicolor or virginica. Parang ganon. Pag mahaba yung length, ayan o. So yung green, yun yung cluster 2. Yun yung cluster 2. So mahahaba yung mga ano ba yan? Sepal o petal? Yung petal. Ito yon yung malalaki, yung mga nasa gilid. Tapos yung sepal, yung nasa gitna. Okay? So pag mahaba yon, ibig sabihin, cluster tree siya. Pag mataba naman yung petal, pero maikli yung petal, cluster, ano siya, cluster blue or cluster what? Ganon. So may clustering pa rin siya, no? Yan. So our third example is the diabetes dataset. So tingnan natin ang itsura ng diabetes dataset. So let's say diabetes feature names. So sa diabetes dataset, we have age, sex, BMI, BP, S1, S2, S3, S4, S5, S6. Okay? So ang target niya, syempre, ano ba ang target ng diabetes? Meron or wala, di ba? Target names yun. Target names. So this is the target. Wala na bang target names to? Target file yung nakalagay. Yun lang. Wala siyang target names. Okay. So, wala talaga tong target. Pag ganito siya, pag target niya is continuous value, pag ang target niya is continuous value, wala siya talagang target. And this is a regression data set. Pwede ba natin itong i-cluster? Pwede pa rin. Pwede natin itong i-cluster. Pero ang tingin ko mangyayari dito, may mga values na magka-cluster-cluster. Let's say, yung mga values na 151, may range yan. So may mga range yan na magka-cluster-cluster. Tapos may mga range yan ng less than, let's say, less than 100, magka-cluster-cluster yung mga yan. So tingnan natin. Pero sa totoo lang, etong continuous values na target, maaari tayo ditong mahirapan sa pagka-cluster kasi ang daming values nito. Pwede natin gawin dito is we normalize this one na kapag more than 150, diabetic na siya or diabetes. Pag less than 150, ano siya, hindi siya diabetic. Parang ganon. So, pwede natin gawin dito, dalawa lang siya. It's either 1 or 2. So, i-run natin. So, kukunin lang natin yung mga features such as age, sex, BMI, BP, S1, S2, 3, 4, 5, 6. Okay. Now, we will set the cluster to 2. Bakit sinet natin siya sa cluster na 2? Kasi it's either you are diabetic or not diabetic. Something like that. Then we will fit that in our Kmeans cluster and we will get the labels. So let's run. And this is the result of our cluster. Okay. So if we will try to cluster them, something like this will happen. So best using BMI and age. Or we can cluster it using, ano kaya pwede natin i-cluster? Age and BMI. Pwede naman. Sige, age and BMI. So, yung cluster 0 is, kung mapapansin niyo yung cluster 0, dito siya nag-start. Pwede ko ba itong i-edit? Hindi. Sayang. Kala ko pwede mag-drawing. So, mapapansin niyo, meron siyang taas, tapos meron siyang baba. So, usually, pag napunta ka sa taas, cluster 0 ka. So, possibly, meron kang diabetes. And then, pag nandito ka sa baba, possibly, hindi. No? So, pinapakita kasi nito, BMI, ibig sabihin yung, yung optimal weight mo. Yung mga underweight, kadalasan, hindi sila diabetic, yung mga underweight. Yung mga overweight, yung mga nasa taas, at patanda ng patanda, sila yung nagkaka-diabetes. So kung mataba ka at matanda ka, nag-accumulate na yung age mo, you are going towards diabetic na. Pero kung bata ka lang naman at payat ka naman or hindi ka masyadong mataba, napupunta ka doon sa hindi diabetic. So may mga tao na hindi diabetic pero mataba. Kaya nag-overlap yan. Kaya siya nag-overlap sa gitna. May mga tao naman na payat or underweight pero diabetic sila. So nakukuha niyo ba yun? Interesting ba sa inyo yung clustering pagka ina-analyze niyo na? Katulad nito, totoo yun. May mga payat, may mga hindi mataas yung BMI, payat sila, ibig sabihin. Pero diabetic sila. Kasi ang diabetic dito yung blue eh. Meron din mga matatabang tao, kung mapapansin nyo dito sa right side, upper right, may matatabang tao at matatanda. Hindi naman sobrang taba. No, kung mapapansin niyo, sakto lang yung taba nila, less than 10. So siguro mga ano lang yon, normal weight. Yung mga normal weight, kahit tumanda, hindi sila diabetic. Okay, so nagbibigay siya ngayon ng insights sa atin. So kung gusto mong makaiwas sa diabetes, dapat habang tumatanda ka, hindi lumataas yung weight mo para makaiwas ka sa diabetes. Yun yung sinasabi nito, BMI at saka age. Right? So nilagay natin yung target ng diabetes dito. So ibig sabihin, pag kinopya ko to, yung value na to, so nilagay ko dito sa baba. Ano nang pangalan niya ngayon? Group. Cluster group. Cluster group. So yung cluster group, TF diabetes. Ay, hindi. Ayan, kung mapapansin niyo, if you will try to notice, yung may mga diabetes, tingnan natin yung result na lang dito. VF underscore diabetes. Ang kanilang cluster at ang kanilang diabetes value. DF underscore diabetes cluster. Ay, nawala. Teka, ito. Ano ko to? Ayan. Okay, so tingnan natin. Ano? Ngayon, lagay natin dito BF underscore diabetes dot cluster is equal to 0. Tingnan natin, no? Okay. Yung mga diabetic, 150 above. Kung mapapansin ninyo, no? Yung mga 150 above. Pero mapapansin kayo may 63. So itong 63 na to, matik yan, outlier yan. Ibig sabihin, outlier yan. Kasi hindi siya average. Oh. So yung mga 1, yung mga hindi diabetes, baliktad no? Dapat yung 1, yun yung may diabetes. Pero yun kasi yung cluster. So yung 1, this is the non-diabetic people. Kung mapapansin niyo below 150 siya. Kasi ganun talaga yung diabetes, no? Pag ang sugar level mo is 150 below, hindi ka diabetic. Ayan. So ang ibig sabihin lang nun, lagi nating i-test ang sugar natin at dapat hindi tayo lalampas sa 150 para hindi tayo maging diabetic. Ayan. So yan yung results ng diabetes sa clustering. May question ba kayo dito? Question? Kung wala kayong question, try ninyo itong zoo data. Punta kayo dito sa zoo dataset. Ayan. Kunin nyo itong dataset na to. And itest ninyo itong dataset nyo sa clustering. Dito, mag-start kayo sa teka. Tulungan ko kayo pala dito. Sige, gawin din natin itong zoo dataset. So, dinownload ko yung zoo dataset and i-upload ko siya dito. Ayan. So, kunin lang natin yung kuha tayo ng code sa taas. So, ito. Zoo dataset. So, BF. So, zoo underscore data. CS. Ayan. Tapos, so tingnan muna natin yung values. Ito, tatanggalin ko kasi itong type, no? Yung type na yan kasi yan yung class. So I will drop the type. Okay. Run ko ulit. Ayan. So yung una, nandyan yung target natin, which is type. So we have our target type there. And because this is unsupervised learning, we need to remove the target or the class. So in this example, I remove the type, which is our target. Next is we're going to get the cluster value. So yung cluster natin. Ito, so this one, to perform the Kmeans clustering. So this will perform the Kmeans clustering. Let's say our cluster is around 5. Okay. So our is DF-zoo, diba? So we will change this one. DF-zoo. Okay. Sure. K-means advert. Oh, I need to also remove pala the animal name because last time sorry, I said earlier that we should not implement any continuous, any nominal or categorical values. So I will also remove animal name. So let me run this from the start and then animal name. Okay, animal name. Okay. Okay, so I remove the animal name and the type. Animal name, why did I remove it? Because actually the names are not really relevant to the computation. So in some other cases, you transform the categorical into a numerical. But in this case, since the name of the animal is actually uh, not going to affect the computation of our K-means clustering, we can simply remove them and put them back later. Because in the K-means clustering, we don't split our data. We don't do training and testing here. We are doing it totally all throughout, or the totality of the data set. We will not remove anything. So we can put the name back later, and also the type after we classify, or after we put the target value on our data set. Okay, so let's run this one. K-means cluster, zoo, random state 5. Next steps is to basically provide the visualization of our cluster. Okay, so ito pala yung next muna. To get this. Okay. Next is this one. Okay, before that, let us view the DF dataset. So the DF dataset already has now clusters. Okay, so first we want to know, we put the name of the clusters again. Okay, so we put again the name of another one. We bring back again the names of the animals. So we bring back the names again of the animals by simply using df underscore zoo animal name equals df, what's that? Ano yung gagamitin ko pala? Nako. So gawa tayo ng bago dito. Siguro df underscore. Ayan. So yung df underscore, magiging siyang df zoo. Okay. So df underscore. So yung df underscore, kukunin natin sa kanya again yung animal name. And then ita-transfer lang natin siya ulit doon sa bagong df zoo. And then also, so df zoo, ilalagay natin din yung type. Ibabalik natin yung type. No? So df underscore zoo underscore is the type. So balik natin. Ayan. So look at this one. Okay. Look at this one. df underscore zoo. Ayan. Nabalik na yung animal name at saka yung type. Right? So, pag kinuha natin yung data, let's say kunin natin yung data ng cluster. Tapos kinuha natin yung type. Tapos kinuha natin yung animal name. Siguro yung animal name dito natin lagay. Animal name. And then the condition, df underscore zoo dot cluster is equal to 0. Tingnan natin. So we will now know what is the meaning of our cluster. Okay, so this is the result. Using the cluster 5, yung advert is cluster 0 and type 1. So tingnan natin yung mga nag-deviate na lang. May 5, frog, newts, toad, tortoise, tuatara, wolf. Ayan, di pala. Toad, tortoise, tsaka tuatara. So these are cluster 0. So ibig sabihin, meron tayong konting error if we're going to implement cluster 5. If we're going to implement cluster 5, may mga nag-error tayo. Yung frog, cluster 0 din daw yung frog. So frog is also cluster 0. So that's an error. Newt is also cluster 0. But what is newt, by the way? It's type 5. It's a different animal. Ano ba yung type 1? Type 1 are most of the time mammals. Right? Type 1 are mammals. Because if you will try to look at this, cheetah, deer, elephant, frog, elephant, giraffe, goat, hamster, hare, so they are cluster 1. How about cluster 2? What are those animals? Okay, so we got perfect score for type 2 and cluster 2. So let's look at the different animals. Chicken, crow, dove, duck, flamingo, gull, hawk, kiwi, lark, ostrich, parakeet, penguin, pheasant, rhea, skimmer, skua, sparrow, swan, vulture, wren. So what are their types? They are type bird, right? So type 2 and cluster 2, it's correct. It's a bird. So how about cluster 3? What are the animals for cluster 3? So we also have mixed assumptions with cluster 3. However, cluster 3 is crab, crayfish, flea, nut, honeybee, horsefly, lobster, moth, octopus, scorpion. Probably these are animals that had many feet, right? The number of their feet is more than 4. Probably that's the reason why they are clustered together. However, some of them are ocean creatures and some of them are land creatures as well. Okay, so we had a little bit of overlapping with cluster 3. How about cluster 4? So fruit bat, girl, gorilla, sea lion, squirrel, vampire, wallaby. So this is cluster 4. They are also mammals. However, look at this closely. Girl and gorilla. Diba? It's interesting that a girl can be clustered with a gorilla and a vampire. Vampire doesn't mean a vampire person. There is an animal actually which is a vampire. So, girl, yeah, girl, fruit bat. Oh, di ba sabi nila yung COVID daw galing sa bat, o fruit bat, and girl. Yan, cluster 5. So the last cluster which is 5. I I forgot. We start with zero cluster pala. Zero cluster. So zero cluster is mammal. 2 is birds. 3 is somewhat sea creature and insects. 4 I don't understand. And we don't have any more with 5. So using 5 clusters, I think it's still not appropriate. So let me extend that to 7 clusters or 6 clusters instead of 5. So if I'm going to use 6 cluster, I will start modifying this one. I'm going to use 6 clusters and okay. So I need to run this from the start again. Run because if I will not, it will have an error. Okay. Sorry for this one. Is cluster 0 the same? I think it's better, right? Why did it why did it become better? It became better because there is no more overlapping. Okay, very good. So cluster 6 is better than cluster 5. Let me just look at cluster 2. Cluster 2, there is no more overlapping as well. Cluster 3, there is overlapping. Cluster 3, there is an overlap. Cluster 4, no more overlapping in cluster 4. Cluster 5, a little bit of overlapping. And then cluster, no more, only cluster 5. So if we will still increase the value, we might get the optimal clusters. Let's say cluster 7. But how about cluster 1? Cluster 1. Cluster 1. For cluster 1, we have a lot of fishes. But look at this one. Dolphins are mammal. However, they were clustered 1 because they are more like fish instead of a mammal. So it's good to cluster them with the fishes instead of the other mammals. So our algorithm is correct. So this is the nuances that I'm telling you. So it's good that our algorithm appropriately selects dolphin as a fish rather than a mammal. Because logically, if you will put out the dolphin from the sea and put it on land, it will die. Because although dolphins are breathing oxygen or land air, their natural habitat is still the sea or the ocean. So our machine learning algorithm appropriately selects dolphin as a cluster of sea animals. All right. How about graph, uh, creating a graph? So cluster groups, so instead of using age, probably we will use what data kaya ang pwede natin gamitin. We can use cluster and legs. Cluster and legs, I think. No, I don't think so. Probably. What can we use? Uh, I think we can get some values from the K-means. K-means, K-means, K-means. K-means dot cluster centers, features in it with the clusters, features, scores. Okay, so we can get the cluster centers, K-means cluster centers. So for this one, for us to plot, we will use K-means cluster. K-means cluster centers. So we can get the K-means cluster centers and selecting the first column. We select the first column and then we select also the second column. Okay. For the color, do we have a color? Ah, I see. So we can copy the code for the color. This one. There's How many clusters is that? 0, 1, 2, 3, 4, 5, 6. So if color 0 is red, blue, cyan. Okay, so colors. And cluster. DF zoo. Group by cluster. Cluster groups. Cluster group. Name. What's this? Personal close. Okay. But green lang. Sure. Color. Fine. Cluster name. One, two, three, four, five. Five. May nag-overlap siguro. Ba't 6 na lang? Group by cluster. Wait, kaya pala 6 na lang. DF Zoo cluster, cluster 1. DF Zoo group by cluster. Cluster groups. DF Zoo. DF Zoo naman siya. Label cluster. Oh, Okay, so this is the visualization of the clusters for the 6 clusters that we have. Save. So how can we interpret this? Cluster 0 is actually 4. Cluster 0 is with regards to legs. Usually apat ang paa ng mga nasa cluster 0. So we can say that they are mammals. 4 legs. Sa cluster 1, wala silang paa. So we can consider them as fish because fishes don't have feet. Cluster 2, bipedal or dalawang paa. So yung mga nasa cluster 2, mga manok siguro yun. Manok. And yung mga bipedal, mga manok, ganun, ibon, ganun. And yung cluster 4, ganun din. Overlapping sila ng cluster 2. Then, yung cluster 5, it can be more than 4. It can be sometimes 5. And then cluster 3, when it comes to legs, 6 or 8. So imagine nyo na lang yung mga animals base sa legs nila. So maka-cluster ka dun sa cluster na yun if you have more than plenty of legs. Okay? So do you have any questions with clustering?
Sir, paano po malalaman kung magsa-stop na parang kung hinuhulaan ba natin kung ilan yung class?
So I'm going to share to you the final code. May question ba kayo sa clustering?
Paano po, sir, malalaman kung magsa-stop na dun sa pag-test ng cluster?
Okay, go ahead. How do we know when the number of cluster tested is correct? Okay, so there are different ways to know if your cluster has the optimal number of K. There are many ways. One way, or the crude way. The crude way is guessing, starting from 0 and then observing the output just like we did here. If there are more overlaps, meaning we need to increase our cluster number. So that's the crude way. There is actually a more scientific way of doing it called the elbow method. So to test if it is correct, there is no correct, wrong or right answer in clustering, unlike in classification. But we all know that there is a reason why you are clustered on that group. And all you need to do is to find the reason why you are clustered to that group. There's no there's no actually evaluation when it comes to clustering. So clustering is just made for clustering and finding the optimal number of clusters to use. So finding the normal clusters to use is to implement the elbow method, something like this. So I already have the code for elbow method. So it will also use the iris dataset. Okay, let me run the code. Okay, so this is the elbow, the optimal number of K. So for the iris dataset, the optimal number of K is actually 3 or 4. How do you know? The highest plunge is 3 rather than 4. If you will notice, 4 and 5 is almost the same. However, the stiffness of the downslope of 2 to 3 is very steep. Therefore, the optimal value of clusters is 3 using the elbow method. So this is the elbow method formula where we get the inertia. So what happens here is that it calculates the cluster and then trains the cluster over and over again to perform the inertia. And then once it finishes all of the value of clusters in our data set, it will plot the value like this. So let me just use different data sets. We can implement instead of the iris dataset, we can implement the zoo dataset. So the zoo dataset will be so do zoo dataset, and then we will implement that here. Zoo dataset. If oops, but we need to remove the animal and the type. So remove the Animal. Remove the animal name, then remove also the type. Then we ran the program. DF. Ano sabi niya? Artwork. Oh, wait. Sorry. This one. Wrong paste. Sorry for that. Wrong paste. Again. Okay. With this one, the optimal number of cluster, according to the elbow method, the optimal value can be 4 or 5. Can be 4 or 5. Or 6. Okay, so yeah, so if the answer is 6, it's still good because our previous answer for our K is 6. This one. So the optimal value of K, so we start with 6. Yeah. So again, there is no way of actually telling, there is no evaluation for clusters. All you need to do there is to prove the number of selected cluster. So the only way for you to say that your cluster is optimal is to implement the elbow method. Because that's the only mathematical way we can say that what we are inferencing is backed up by mathematics. Okay. Because there's no other evaluation to test clustering. Unlike the supervised learning, we can use accuracy model where we can get the mean square error of the actual and predicted values. Unlike this one, we don't have any. We just need to back up our point that the optimal clusters are 4 or 5, and then the clusters are backed up by the optimal choosing of K, something like that. So probably the only way for you to take a what do you call this, an evaluation, is to have a human evaluation. There is actually a way of evaluating your outcome, which is human evaluation. So you will provide a survey. You will provide a survey from your clustering algorithm. If the result of the clustering algorithm is according from your survey past, okay, or rational, therefore your result is approved or correct. So in this scenario, since we don't have any evaluation techniques for clustering, you can perform human evaluation. So what you're going to do is to show them your outcome, something like this, in your analysis, and then let your reviewer vote. The accuracy of your result, something like that. That's my 2 cents. If you really wanted to provide an evaluation of your algorithm. Yeah, because when I was also studying clustering algorithm, we were not taught of evaluating the result. What we just had is this elbow method or the silhouette method. There is another one, the silhouette method. Actually, it works the same thing with the elbow method. So it's either you use the elbow method or the silhouette method to know the optimal number of clusters that you will use on your K-means cluster. Then if you really want to have an evaluation of your result, provide a survey and then also show your results. Therefore, it will be validated by the people that are, let's say, experts on that matter. In this case, since we are using the animal data set, I think general knowledge is enough to be an expert to know if this animal is part of the mammals or part of the birds or fishes. Yeah, so it's enough to have a general knowledge. So you can actually get a survey from those people, from your clustering. So the importance of clustering, this is a exploratory analysis to know the clusters on your data, where it can provide the separation of nuances or the overlapping, or it will provide information of the overlapping nuances on your data set. Just like what we did with the dolphin is categorized as fish, although originally a dolphin is a mammal. But logically speaking, you cannot really put the dolphin outside of the ocean and let it live with the other mammals. That's not going to happen because dolphins' environment is the ocean, or water is the natural environment of the dolphin. Although dolphins are still considered mammals. So that is the nuances that K-means clustering can provide to us. So probably you might think of different kinds of ways how you can implement K-means clustering on your data sets. Example question, paano sir, for example, may noise sa data or may missing null data, do we need to drop them? Okay, so the noise in the data can be determined also using clustering. That's a good observation or business case. You might want to use clustering to get the right clusters for testing. You can simply drop them. Let's say if you have a sensor of water, and you want to know if the water is boiling or not. So if you want to know if the water is boiling, it needs to get sensors just right around 98 to 100. So anything above that is already an outlier. So you can basically drop that information, right? So in order for you to know if you have an outlier is to know your standard deviation and your averages. So you need to also get something from qualitative data. Yeah. Basically, you just don't implement averages and standard deviation. You also implement normal distribution on your data set to know if there are outliers. But when you say outliers, it's a term that we use whenever there is a miscalculation or an error on our data. However, errors in our data is also garbage in, garbage out. What I mean by that is, in order for us to get a good result from our machine learning algorithm, we really need to clean first our data. So the errors that we encounter from the machine learning models that we use are actually our fault also. If we're feeding the machine learning algorithm with dirty data, you will also get dirty data results. You will also get dirty results. So it's really, really important to clean your data so that it will not provide any outliers on your results. So what can be the reason of outliers or errors on our data set? If you're talking about machine learning per se, your data should be balanced or normally distributed. Anything that will make it overfit will produce error. How do you provide overfitting on your model? So you provide overfitting on your model if you do not sample enough. If your data set is biased, how do you create a data set that is biased? Let's say you create a random sampling and you wanted to get or gather your data on the comfort of your area. Let's say you want to get a survey of the national average cost of living of a person in the Philippines. If you get the data only inside your barangay, guess what? You will get a biased data. That's why big data and machine learning is they are like brothers and sisters, because when you talk about big data, you are also saying that there is no bias on that data because that is being harnessed from different sources. Let's say Facebook posts. That post is not coming from a single person, it's coming from different people. So you can basically gather all the sentiments of the people and discover what's making them sad, what's making them hate another person, what's the trending news, what is the viral thing going on nowadays. You can basically do that. So that's why Facebook is a multi-billion company, because Mark Zuckerberg is getting information from billions of people, and using machine learning, he can cluster different kinds of people and shoot them with the right marketing campaign. Let's say if you are always clicking air fryers, if you are always searching for air fryers or also seafood on your Facebook account, guess what? You will be learned by a machine, and all the ads that you will get are about air fryers and seafood. Correct? Did you notice that? Press 1 if you notice that. So now, does it make sense how Facebook is understanding us, how Netflix is understanding its customers? Basically, it's just machine learning. It's clustering us. They are clustering different kinds of customers. Therefore, they optimize their marketing strategy by knowing the right person to target with the right marketing campaign. And what will it produce? It will produce sales, of course. It will produce revenue. Therefore, Facebook provides value, and data is the next fuel. Or that's why there is a saying, data is the next fuel. You will basically earn money because of data. That's also the reason why we are studying this one, so that you will tap into that opportunity and become data scientists in the near future. Yeah. So do you have any more things to ask? We did not have any breaks, no? But are you happy with it? So we tackled supervised learning, clustering. This is what you have already, because I have discussed a lot of things to you. Your understanding is now, you already know what is regression, you already know what is classification under supervised learning. And then this one, you learn unsupervised learning by means of clustering. Yeah. So this clustering method is the estimation of the scatter plot and the distances of them inside the Cartesian plane. Okay. I'm looking for data set that you can actually practice on. What clustering data set kaya? Do we have other data sets here so that we can implement? ano, if you're gonna submit that, uh, prepare a Medium account. Yun lang naman, Medium account. Tapos naman sa picture. Duration. Job. Purpose. Job 2, job 1. Oh yeah, of course, I'm going to check it first. So this is an interesting data set, but you might want to use. So this is bank customer segmentation. You can implement clustering on this data set, by the way. So if you will try to notice on the data set, the data set has categorical values such as male, female, male. What you need to do there is you need to transform it in such a way it will become numerical. And then the other information such as housing, this should also become numerical. Savings account, numerical. Checking account, numerical. So you will also observe that there is a none. So for that, you want to check that, or you want to replace that with 0. If you see a none, not a number. Credit amount, duration. For this one, the purpose of TV, you would also transform this. Okay. Unique. Okay, so it has examples of clustering, as you can see. So the distribution is skewed to the left. Therefore, the data set has a lot of values. Skewed to the left. It's not normally distributed. So, or probably the normal distribution is around 0 to $10,000. I like this depiction of the ooh. 3D. Ito, SVM. SVM to ginagamit to 3D. Ito, little bit normal. Okay to. Credit amount, normal. Duration, quite normal, but cluster data. Pwede to. I suggest this one, pwede siya. So, ang gagawin na lang dito is you will try to implement some kind of like transformation dito. Okay. Sir, yung purpose po yung i-cluster namin. Naming? Naming? Nag-autocorrect. Namin. Sir, yung purpose po yung i-cluster namin. Purpose. What do you mean purpose? Yung context ba? Purpose field po ba yung cluster? Purpose. Purpose. Doon sa dataset, are you pertaining to the dataset? Ito, purpose. So, if you're pertaining to the dataset purpose, no, you're not going to cluster based on purpose. You want to cluster and analyze what kind of people are being clustered here. So, as you can see, wala siyang target, and we can also say that the purpose can be considered as a target. Possibly, yes. But if that is a classification problem, we can use purpose as our class. However, if this is the perspective of a clustering, probably I want to cluster them based on their customer segmentation, credit score, probably. So, kaya ko nasabi na wala dito yung target kasi what I'm thinking, the supposed target should be credit score. Yun yung nasa isip ko. Kaya ako nasabi na wala dito yung target. Pero kung sasabihin natin na yung target natin yung purpose, ang magiging classification natin dito is yung mga customers natin usually gusto nilang bumili ng radio, TV, education, furniture, car purposes for loan. Okay, anyway, may papakita ko sa inyong code. Ito yung tinatawag nating one-hot encoding. So this is get dummies. Let's say our data set is having numerical values, and at the same time, it also has red, blue, green, which is a categorical value. So implementing get dummies on that data frame with a column of colors. So magfo-focus lang siya sa column na colors. Ang gagawin niya, magta-transform yan into like this. So let me separate them. So ito yung original niya na data. Pag in-implement natin yung one-hot encoding, so it will take few minutes, like one minute or less than 2 minutes. We just wait. So it becomes something like this. Did you get the idea of the transformation? Hello? So what happened there is, yeah, so that's what you need when I say you make all of the columns numerical. So originally our data is ID and color red, right? When you do one-hot encoding, we can do this in Excel actually, but doing that will cost us a lot of time. So what we did, we use Python and pandas. We implement one-hot encoding, right? So it happens that in the original value, ID1 is color red. Therefore, we get to transform color into 3 columns and then naming them the actual values from the previous data set. So we have color underscore blue, color underscore green, color underscore red. So we have here, so value of color underscore blue is 0, color underscore green 0, and color underscore red is 1, for the reason that the original instance is red. Same goes with ID2. So this is blue, therefore we have 1 here on the column color blue, and then green, and then red, 0, 0. And that goes to the other transformations. So if you are thinking that you will be transforming this, ano sana ba yun? Bank customer segmentation, you can do one-hot encoding in this one. Right? You can do one-hot encoding for this one. So let's say I'm going to hard code that to my, so let's say we have another one here. Purpose. So the purpose is TV, radio, car, education. Okay, guess what? I can purpose, education. Same length. Oh, sorry. Another one. Other. Okay. Or you can say that there are 2 educations. Okay. So we will just going to add another column here, which is education. And the result, education. Bakit ganun? Tama na yung player code ko. Purpose. Ba't ba education na nasa isip? Purpose. Ayan. Yeah. So it will make it like this. Let's say also you have another one, gender, male, female, 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 male. So if this is your data set, you have a lot of categorical values. If you implement here using the one-hot encoding, you will transform them into this. Okay? So that's the way you would transform your categorical data to a numerical version of your data. Okay? Any more questions? You can practice that at home. You can cluster the bank customer segmentation. Okay. So let me just add this to our Leon account. We can practice the bank segmentation periods. Okay, do you have any more questions? By the way, okay. So I think next meeting I will not be available in the sessions. So I don't know if I just submitted a leave of absence for next week. And I think that might be approved. So if that will be approved for next week, we won't have our session 8 this coming July 29. So instead, it will be August 5 and 12, 19. 19 will be our final session. Usually in the final session is just presenting ito. Okay. Yeah. Do you have any more questions? I think we can call it a day. If you don't have any more question, we can have an early session. Yeah, so we can take our early out today if you don't have any more questions. Okay, press 1 if you have no more questions. So I will upload this lecture later so that you can watch it again and review. So thank you and see you next meeting. Bye.